Hello students, today let's discuss about the basics of design of column. We'll also discuss the various guidelines given by IS 456 2000. So what is exactly column? A compression member having its effective length greater than 3 times its least lateral dimension is called as column or strut. So in general, vertical compression members are called as columns and inclined compression members are called as strut. So let's see this diagram. Here, whatever these vertical compression members are given here, these are called as columns, and this is the one inclined member which is provided here from this corner to this corner. So it is called as strut. Pedestal is one more term which is normally used. So it is the compression member, the effective length of which does not exceed 3 times the least lateral dimension. Well, so pedestal are the small columns having less length. Some terms are important here. One is unsupported length of column. So it is the clear distance between end restraint. In slab beam construction, it is the clear distance between the floor and the underside of the shallow beam framing into the columns in each direction at the next floor level. This is one floor level, this is the top level of the floor level, and this is the underside or the soffit of the beam.
So one effective length is from this face to this face, and second effective length is from this face to this face. Now in general, if you are talking what is unsupported length, then whichever is shallower beam, so that length is to be considered. So this is your shallow beam and this height is your unsupported length. But if I consider the major and minor axis of the column, so obviously this is my XX axis and this is the YY axis. So this XX axis. So about XX axis, which is the unsupported length, so obviously this is the unsupported length, and about the another minor axis, let's say this is YY, so this is the unsupported length. Well, the next term is effective length. So effective length, it is the vertical length of compression member between the points of inflection, also called as counterflexure, of a buccal column in a plane is termed as effective length. So the notation will use as L suffix E of that compression member in that plane. That means about X and about Y direction, effective lengths can be different. The effective length is different from the unsupported length of the member. The relation between the effective and unsupported length of any compression member is given as LE is equal to K into L. Now, where K is the ratio of effective length to unsupported length. So, in IS 456, in this table 28, effective length of compression member is given. So, this is the theoretical value and it is the recommended value. Now, in this, we will find all these, what are the factors are given. This is 0.65 L. It is both end fixed. Here one end fixed, another end is hinge. It is 0.8 L. When both ends are hinged, it is 1 L, and likewise the remaining conditions are given here. So here L is, yes, here it is given, L is the unsupported length of the compression member. So we just saw how to find the unsupported length, okay, and then according to the condition we have to multiply by the factor. By using this K factor, you get the effective length. Well, in IS 456 clause 25.3, also the slenderness limits for the columns are given. So the unsupported length between end restraints shall not exceed 60 times of B. What is B? B is the least lateral dimension. And further, second point is given as unsupported length of cantilever column shall not exceed 100 B square by D, and where D is the larger lateral dimension and which is also restrained up to 4 times of B. Okay, so this is the additional line which is given. That means the depth is restrained to 4 times of B. Well, short and slender compression member, this is one type of classification, also called as short and long column. So according to IS code, a compression member may be considered as short when both the slenderness ratio, that is LEX by D and LEY by B, are less than 12. Now here you have to understand that
if this is my depth of the column, this is D and this is B. So this axis is XX axis. So bending is about XX axis, so it is divided by D. And if bending is about YY axis, it is divided by B. So that is how LEX by D and LEY by B. If these are less than 12, then the column is called as short column. So what is LEX? LEX is effective length in respect of major axis and LEY is effective length in respect of minor axis. Now what is this major and minor axis? So the definitions are given here. The major axis of the bending XX, so this is the XX axis, is taken as the axis bisecting the depth of the column. So this is the depth of the column. The larger side of the column is always called as depth, and the axis which bisects depth of the column is called as XX axis. Similarly, the minor axis of the bending YY is taken as the axis bisecting the width. So here is the width of the column, and this is the axis which bisects width of the column, that is called as YY axis. Now in this equation, another two terms are given. So depth of the column, so this is the larger side which is called as the depth, and this is the smaller side which is called as B, small b. It shall otherwise be considered as slender column. That means if this ratio is more than 12, the column is considered as the slender compression member. Well, now minimum eccentricity. So in actual practice, columns are rarely truly axially loaded. Well, there are many reasons. There may be some eccentricity, load transfer eccentricity during the construction. Due to non-homogeneity of the materials, the eccentricity may be there. Well, so it is necessary to consider that minimum eccentricity, and that is given here in this clause 25.4. Well, according to this clause, eccentricity about x-axis is denoted as EX minimum, and that shall be greater than L by 500 plus D by 30. So what is L? L is the unsupported length, and D by 30, D is depth of the column, or 20 mm. So greater of these two values. Similarly, the eccentricity about y-axis EY minimum, that shall be greater of again L by 500 plus B by 30 or 20 mm. So greater of these two values. So this is minimum eccentricity. Well, now this minimum eccentricity we have to consider in the equation of axially loaded column. So that we'll see later on while dealing with the axially loaded column. Now there are two types of reinforcements in column. One is longitudinal reinforcement and second one is transverse reinforcement. So why longitudinal reinforcement is necessary? So more or less columns are always subjected to buckling due to eccentric loads and end moments, and hence longitudinal reinforcement is required along all faces running parallel to the axis of the member. That means this is the reinforcement which is provided along the length of the column. Well, what are the functions of longitudinal reinforcement? So one by one we will see. First one, to assist concrete in resisting compression so as to reduce the size of the column. That means the load carrying capacity of the steel is quite higher as compared to the concrete, and obviously if you add some percentage of the steel, it reduces the size of the column. To resist any tension that might develop due to bending caused by transverse load or buckling caused by eccentric loads and end moments. To hold the transverse reinforcement in position. To impart necessary ductility to the columns. To reduce the effect of creep and shrinkage of column. Now what is this creep and shrinkage? Well, creep and shrinkage meaning it's same, that is it's the reduction in volume of the concrete, but the reasons are different. Shrinkage is because of loss of moisture and creep is because of sustained loading. Well, both the actions are inelastic actions. Well, so you can reduce this, the effect of creep and shrinkage, by adding the reinforcement to prevent or delay the sudden brittle collapse of column. Well, IS 456 gives some guidelines related to longitudinal reinforcement, and these guidelines one by one we will see. Well, the cross-sectional area of longitudinal reinforcement shall not less than 0.8%. So this is the minimum percentage of steel which is mentioned, and not more than 6%. Well, this 6% is again reduced to 4%. In which cases, let's see. Well, 6% of the gross cross-sectional area of the column, where the bars from the columns below have to be lapped with those in the column under consideration. That means whenever we need lapping of the bars, so in that case, to avoid congestion of the reinforcement, this percentage of steel 6% is reduced to 4%. The second point, in any column that has a larger cross-sectional area than that required to support the load, the minimum percentage of steel shall be based upon the area of concrete required to resist the direct stress and not upon the actual area. So sometimes the more size of the column is provided. So in that case, this minimum percentage 0.8 must be calculated based on required area and not the provided area. Well, the next guideline is the minimum number of longitudinal bars provided in the column shall be 4 in rectangular column and 6 in circular column. Well, again the bar diameter shall not be less than 12 mm in diameter. The reinforced concrete column having helical reinforcement shall have at least 6 bars of longitudinal reinforcement within the helical reinforcement. In a helical reinforced column, the longitudinal bars shall be in contact with the helical reinforcement and equidistant around its inner circumference. Spacing of longitudinal bars measured around the periphery of the column shall not exceed 300. Now, this point we have to look along with this point, minimum number of bars. For example, if size of the column, let's say this is 300 and this is 450. According to this clause, minimum number of bars are 4. So let's provide here 1 bar, 2, 3 and 4. The cover for the column bar is 40 mm. So from both sides, even if you subtract 40 mm, so this is 450 mm, 450 minus 80. So that distance is more than 300 mm. So this point says that distance shall not be more than 300 mm. That means it is necessary to add additional 2 bars here. Okay. So that's how this point also governs the criteria for minimum number of bars. The next point, in case of pedestal in which the longitudinal reinforcement is not taken in account in strain calculation, the nominal longitudinal reinforcement not less than 0.15% of the cross-sectional area shall be provided. So this is in case of pedestal and the percentage of steel is given as 0.15. Well, the second type of the steel, that is transverse reinforcement. So transverse reinforcement bars are provided in the form of circular rings or polygonal rings. These are called as lateral ties and with internal angle not exceeding 135 degrees. So if this is the link, okay, this is the link which is provided here. So this angle is 135 degrees. So obviously internal angle is 45 degrees. And this length of that hook, that must be 10D or 75 mm, whichever is more. What are the functions of transverse reinforcement? To hold the longitudinal reinforcement in position, to prevent buckling of longitudinal bars, to confine the concrete and to prevent longitudinal splitting of concrete, to resist diagonal tension due to transverse shear, and the last one, to impart necessary ductility to the columns and to prevent or delay sudden brittle failure of column. Well, while designing this transverse reinforcement, just 2 points are given in IS code which are related to pitch and diameter of lateral ties. So pitch means this is the distance between 2 consecutive lateral ties. So the maximum pitch shall be the list of the following. First one, the least lateral dimension of the compression member, that means B and D if you consider. So B is the least lateral dimension. Then 16 times the smallest diameter of the longitudinal reinforcement. So 16 times smallest diameter. So many times we provide combination of the bars. Sometimes 4 bars of 16 mm diameter plus 4 bars of 20 mm diameter. So in this case, just consider the smallest diameter. So smallest diameter is 16 mm. So 16 times the 16 mm. So this is the meaning of this line. And last one is 300 mm. So out of these 3 points, whichever is least, the minimum that we have to consider. Diameter of the lateral tie. The diameter of the polygonal link or lateral ties shall be not less than 1/4 of the diameter of the largest longitudinal bar. Now you have to remember that in this case it is given as smallest diameter, and here it is given as largest diameter, and in no case less than 6 mm diameter. That means if we are considering a column with a combination of bars like 4 of 25 mm diameter plus 4 of 16 mm diameter, now 25 divided by 4, so obviously it is more than 6. So you cannot provide 6 mm in that case, you have to provide 8 mm in that case. Okay? So the bar diameter is 25 or more, then in that case the diameter of the lateral tie is 8 mm, otherwise you can provide 6 mm. Okay, thank you students. In the next part we'll see how to design axial loaded column and uniaxial loaded column and biaxial loaded column. Thank you.